So what is a QSFP? I guess we should start there.
Yeah.
And so, so QSFP, quad, small form factor pluggable. It's an optical transceiver. It can transmit at either a combined rate, let's just say 400 gigabits per second, as a single data rate, or you can break it out into 4 100 gig lanes, okay? So if you break it out into 4 100 gig lane, each lane needs a discrete fiber connection, right? It actually physically breaks it out into 4 different transmissions, okay? So then how does that translate to fiber? How do you get it to individual 100 gig accessible lanes to plug in a jumper?
But why do they, let me ask you this though, why would you need to break them out? Why can't you just go MPO to MPO?
You can go to MPO to MPO. So really what it comes down to, not only is it having the ability to have 4 100 gig lanes, but it's also being able to get 4 100 gig connections out of a single port. So the density of a switch now increases exponentially by 4. 16 port blade on a switch now has the capability of doing 64 ports.
Gotcha.
But in the footprint of 16.
Gotcha. So it's space, power, cost savings.
Density for sure.
Density. Okay, gotcha. That makes sense.
Yeah, so now how do you then take that single interface on a QSFP and how do you break it out into 4 individual discrete lanes? Okay. And you do that with an array cable. So this is your array cable. It's an MPO on one side, and then it breaks out into duplex LCs on the other. And this is how we do it. But what happens if you're only using 1 or 2 of those 100 gig lanes while you're waiting to use the other 2 on something else?
Right.
What do you have to do with it? They just kind of dangle in the rack.
Yep.
And this becomes pretty much of a spaghetti mess.
Management nightmare.
Right? So the real trick is, how can you manage breaking out an MPO into 4 duplex LCs in a way that is more manageable, clean, neat, and a technician that's intuitive to the technician that walks up to the QSFP or walks up to the panel and says, okay, I know this is my breakout. So what's an easy way to do that? This by the way, was your idea.
Well, it was prompted by a customer.
Okay.
Right.
That said, help me.
Yeah. And you know what I think the interesting thing about this is it's not a cabling solution, in that it's driven by the customer's network equipment, right? Because if you remember, they said, hey, do you have a way to break out these? And we're like, yeah, by the way, we do. We have an existing solution. And he said, yeah, but the problem is it doesn't line up port-wise. Right. And there are a lot of solutions in the market that claim to be port breakouts, but they're still all based on a base 12 solution that follows the cabling models instead of the networking equipment.
So what you're saying is that a typical switch has 16 ports on a single blade. Typically, it can. There's others that have different configurations, but for the most part, a switch blade has 16 ports. So if we can develop a solution that had 16 individual breakouts in a 1U, it would line up 1 for 1 the breakout with the ports on the switch.
That's right.
Got it. And just taking that one step further, in a typical solution, breakout solution, you would have a single panel that's closed that would have the quad breakouts on the front of it. If one quad breakout went bad, it's not accessible.
That's right.
And that means, and that translates completely to blast radius, which means one port going bad affects the other 15, because in order to replace that one, you have to replace the whole panel. So if you can reduce that blast radius from 1 to 16 down to an individual blast radius for each individual QSFP, if something goes bad on that QSFP, it's just replace that single one.
That's right.
And that solution is?
That's right. That's the HyperClone.
HyperClone. So tell me a little bit about HyperClone.
So you know what's interesting is, and we're probably going to talk about this a good bit today, but when we're talking about fiber optic solutions, you know, 20 years ago, dating ourselves here, when we would go talk to customers, we talked a lot about fiber.
Yes.
And how fiber worked, and why this fiber is better than that fiber and whatnot. But I think as the market has evolved, it becomes less about, you know, the performance of the fiber and more about how the design, the application, and how that affects customers' business, right, as opposed to, hey, this is fiber, this is how it works, yeah, right? So what we did with this solution was we said, tell us how you're deploying it, and what are the issues that you're concerned about when you deploy it.
Yep.
Right. So with this solution, one of the first things that came up was, well, we only want this thing front accessible. So there are solutions in the market that use a traditional base 12 footprint that have connectivity on the front for their port breakouts, but you've got to access the rear of the cabinet in order to install them.
Yep. And as servers get bigger, the cabinets get deeper.
That's right.
So the access becomes more difficult.
That's right.
Yeah.
And more dense, right? So it becomes a big challenge. So being able to mount a low profile panel in the front and make the entire product front accessible just makes it a lot easier. I doubt that you're going to have multiple network technicians going out to install one of these, right? You want to walk, you know, down 17 cabinets around to the back, right?
Yep.
Or do you want to just pop this thing in right from the front that easily?
Just like that.
Can you tell us a little bit about the module itself and
for
the
sure
design?
Okay, so in the QSFP breakout, as you remember, we had an MPO that plugs into the QSFP, and then the traditional solution had a number of LCs that hang off the front, and you have to manage individually each LC that you would then plug into a server or something. So what we've done is we've actually integrated the MPO into the module itself. Internal to the module, the fiber that's inside here then breaks out into duplex LC ports.
Okay.
Okay.
Got it.
So now you're not trying to manage a leg of a cable, but you can actually plug in an individual jumper. For whatever length you need, you can plug the jumper right from the module into a fiber panel or into a switch or a server, or whatever connection that you need for that duplex LC, that 100 gig connection.
Gotcha.
That started out as 400 gig out of the QSFP with an MPO. So not only is this a neat, easy way to manage your breakouts and plug into the QSFP, but it allows you to individually patch. Gotcha. So now you don't have 4 legs hanging off and 2 being used and 2 just, you know, kind of sitting there.
And I would imagine that there's significant risk by having these exposed legs.
Oh, absolutely. Right? And anytime you can, well, you know what? I don't know, because you're going to have jumpers. The risk comes in the fact that these jumpers, if you don't use them, these legs, then they're hanging, and then there's risk of damage. Right?
Gotcha. Yep.
The fact that you don't have to use a port until you're ready, and then you have a discrete jumper that you plug into it and then patch in.
Yep.
So your breakouts will sit here on these ports at all times, and then you just plug and jumper into it when you need it.
Got it. Got it.
So very clean. And again, 16 ports across the panel. So 16 of these little modules in a single panel.
Yeah.
Right. Allows you to kind of scale your network as well. And it scales right along with it.